Y squared as well.
It is.
Yeah, phone math.
And there is 11, 12, 13, and 14.
Is the mic on? Usually the light is on.
Do you see the flashing light right there?
I don't know, like the light on the mic is on.
The mic is not on. There's no need for the mic to be on. I'm not teaching.
You're right.
You just need to see what's on the screen. If someone asks me a legitimate question, not, Mr. Myers, you wrote down the wrong thing because I use photomath and I know, then I would. Noah. Certainly. See, now I actually have to do some teaching. So I'm going to plug that in there. Oops. Oh. All right. So this is one of those ones that's actually a little bit difficult because the number gets pretty big. But 7 times 6 is 420. 7 times 60. So I need factors of 420 that add to 76. But since that's positive and this is negative, I know that the two factors have to both be negative, right? Which is 70 and 6, because 70 times 6 is 420. So I add u squared minus 70, but it's not minus 70. The only reason I knew it was 70 was because I multiplied by 7. So I have to divide out the 7 at the end. And not u squared, and because I had a v, I have to have a v there, u minus 6 over 7v. Then you simplify. 70 divided by 7 is 10. So I get u minus 10v. And this doesn't simplify. So the 7 moves to the front. 7u minus 6v. And then I can double check. You can always double check in factoring. Because if you factored it right, if you FOIL it out, it works. U times 7u got me 7u squared. Negative 10 times negative 6 got me positive 60. 7u's and, 6 and 670 get me 76. And then in the process there, 14 got erased. But then the next page. There is 1 through 12. Number 4 gets a little crowded, but you should be able to see it. Damn, I'm out of water. Everybody good? Again, please do not copy down the right answer and then try to work it out, because it's been recorded. And there is 5 through 16. Alrighty then. What? Sorry, what? 12. Negative 4, bracket 2 plus 8, bracket 2 minus 4. Now, actually, that's a good question, Isabel. The negative here, we like, if there's a leading negative, we like to bring the negative out. because we don't mind it. And when I say we, I mean math people. It's strictly a convention because in actual fact, -4 isn't the greatest common factor there. This is just something we like to do. We like to take that negative out, which then gives us 4t squared plus 16t minus 128. Because we don't like a negative inside those brackets. But for some reason, math people like it at the very, very front. I don't know why they care. They just do. And then there is 17 through 28. And by this time, the bulk of the room had gone to photomath, so you're just checking these. And there's... What? But they're recorded. I record them so I can have more class time to actually work with you guys. Jorit, which one? Yeah, you could, except x squared minus 1 is another difference of squares, so you have to finish factoring it. Because x has a square root and 1 has a square root. So you have to do that into that. It's blue. I know. Everyone relax. I got it. And then there's the last, I don't know, that many. Yeah. They're cooking. Someone's overcooking something. All right. Page 56. On page 56, we are going to use expansion to teach us how to do factoring. Again, we've done it in the... Oh, excuse me, how rude. We've done it in the past, and we are going to do it again. So, let us expand this. So, the y multiplies all the way through first in order to get y cubed plus 2y squared plus 4y. Then the -2 multiplies all the way through to get -2y cubed minus 4y minus 8. And then when I collect the like terms, I find I have y cubed minus 8. Yeah? Yeah. Now I'm going to do the same thing here. And I will keep the same color scheme. The x all the way through gets me x cubed minus 3x plus 3x squared plus 9x. And then the blue positive 3 gets me plus 3x squared minus 9x plus 27. And then I collect in my sassy pink color, because it's the 27th, y cubed plus 27. And then, cabbages, I look and I see what common trait exists between the terms that are left over. What common trait do all of those highlighted numbers share? That is true. What was it from this side of the room? They are cubes, making this a difference of cubes and making this a sum of cubes. Now, we have seen this terminology before because we know we can do a difference of squares, right? And we got a fancy little formula thing that helped us solve that, correct? Now, most of you should notice something here. I'm going to erase these. Please notice that there are characteristics shared between the green, what's left over, and where we started from. Because, of course, this is a product. And these are, of course, factors. So you should notice that there is a pretty obvious connection between the product and the factors. How does y relate to y cubed? How does y relate to y cubed? Let's make it a little easier on you. How does x relate to x squared? X times x is x squared. So x is what? Try this with numbers. How does 3 relate to 9? 3 squared is 9, so 9 is the square root of 3. Okay, so how then does y relate to y cubed? I don't know why you keep asking us, Mr. Myers. What is the relationship between y cubed and y? It's the cube root, right? What is the relationship between 8 and 2? 8's cubed root is 2. Oh. Let's look over here, shall we? What's the relationship? Oh, damn it, idiot head. Between x cubed and x. What's the relationship between x cubed and x? This is not a trick question. It's the exact same question I just asked 17 times. What's the relationship between x cubed and x? X is the cubed root of x cubed. What is the relationship between 27 and 3? 27 cube root 3, yes? So, if I gave you this, m cubed minus 64, and I said to factor it, what would the first factor be? M minus 4. Yeah! Ding, 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 ding. Okay. Wait. What if I asked you to factor 8p cubed minus 27? What would the first factor be? 2p minus 3. Bing, 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 bing. All right. Okay. Now, please notice, here is a sum and a difference of cubes, yes? Because I have something cubed plus something cubed or something cubed minus something cubed, right? So the first step, notice, x cubed becomes x. So the first thing I do is I cube root the first term. Everybody understand? Then I cube root the second term. Yeah? Yeah. Now, if it is a sum of cubes, then this is positive. If it's difference of cubes, it's negative. Everybody follows that logic, yes? Now, let's look across. Here, I have to have x squared. I started with x cubed. I took out 1x. That leaves me with x squared, right? So whatever x is right there, this is just squared. X squared. Y squared. So in that other example I gave you, m plus 64, you already told me it was going to be m plus 4. What's the first number here going to be? M squared. When we had 2p cubed plus 27, you told me it was going to be 2p plus 3. What's this going to be? Sorry, that couldn't have been 2. It was 8. 8p squared. What's this? Pardon? 2p squared? 4p squared, because you have to square the whole term. Everybody good? So it would be, and then the plus carries on, and the minus carries on. Does everybody understand? Jordan, I'm sorry, I lost you after if you could do, and then you have to include the x, y in the middle. You have to multiply these two things. There's the 3x. Or it won't expand out properly. Okay? So, remember, if I say factor, that means this is a product. And I have to break it down into its parts. Now, does 1 have a cube root? Yes, what is it? 1, because 1 times 1 is 1. Does x cubed have a cube root? What is it? So, the first thing I do is x and y. I take the cube root of that, which is what? 1. Now, since it's a difference of squares, it's going to be plus plus, right? Just like up here, because this is a difference. So, minus, what's y? It's x. Then, I just go through. The first term, squared. What is 1 squared? 1 squared. I'm going to write 1 squared for teaching purposes, but of course I wouldn't. What would I write there? 1, obviously. Then, it's a difference of squares, so it's positive, plus xy. Well, what is xy? What's x times y? Well, in this case, this is x and this is y. So what do I write here? 1x, right? Plus x. And then what's the last thing? It's this term squared. So it's this term squared. What is it? X squared. And it's done. Now, how do you know you did it right? You just check. 1 times 1 is 1, yes? Positive x minus x cubed. Then I check it again, and I would find it expands out perfectly. Everybody good? All right, let's check this one. This one is a sum of cubes. So I'm going to end up with negative positive, right? So the first term is the cube root of that, which is what? X plus cube root of that. What's the cube root of 512? 8. And then x squared. What is it? X squared. It's going to be minus plus minus. What's this? What's x times y? 8x. And then plus, what's this cubed? 60, or squared. 64. Done. Everybody see it? It's pretty easy, right? Can I forget about all my other factorings? Like if I could GCF, should I? Yes. So let's check here. Is this a difference of sum or a difference of cubes? It's a difference of cubes. So I know it's going to be minus in the first one and then plus plus, right? Okay. So what's the cube root of that? 1. Minus, what's the cube root of that? Cube root of 1,000, guys. 10. Cube root of d cubed. D. And then it's x squared, which is what? 1 plus, what goes here? 10d plus 100d squared. Everybody see? All right, now, what's changed in d? There's a coefficient, right? Up till here, we haven't had a coefficient there. But does it really change? No, because what's special about 27? It's got a cube root, doesn't it? What is it? 3. So I take the cube root of that. What is it? 3y. It's negative, so minus what's the cube root of 125? 5. Then I just do squared times squared, right? 9y squared plus, because it's a difference of squares, what's going here? 15y plus 25. Yay! Brilliant. What's different about E? It's a sixth. Oh. And 7 doesn't have a cube root. So golly gosh darn it, what should we do? We should do the first thing that we're always supposed to do when factoring, which is GCF. So this becomes 7x to the 6th plus 1. Now, does that have a cubed root? What is it? X squared. You sneaky. You must have had a very good grade 10 teacher. Stop it, Jashin. Just stop. You're making me blush. Oh. What is the cube root? Jashin has told us it is x squared. What is the cube root of 1? 1. So we write plus 1. What goes here? This is tricky. X to the 4th, because we still are squaring this term. It's plus, so it's minus here. What is it? X squared, and then plus 1. If f was that, could we do it? Sure. If f was that, could we do it? Sure. Because of course we remember from our exponent unit that x cubed y cubed is the same as xy cubed, right? What's the cube root of xy cubed? xy. Plus or minus here? Plus. Plus what? Four. What's here? X squared, y squared. Plus? Minus 4xy plus 16. We did it! We're super smart. Right? Now, of course, all of you erase your work, check Photomath, and make sure I did it right.
Will do.
I know you're all going to, so it doesn't matter. Ria. X squared, Y squared, yeah.
Oh,
It's the last block of the day. Let's finish this week factoring. Let's do 57, 58, 59, 60. That's today. Now, listen, please. If you turn to page 61, you see the word assignment, yes? What does that mean? There you go. Please notice, for the photomathers, I know it shows you all the work, but you're still going to have to copy it all down, which means you're at least writing, and I still get a small win out of the deal. Maybe. There's a chance at that. Now, ladies and gentlemen, actually, it is very important you listen to me. It seems like we're doing a crap ton of factoring, yes? Like, you think, like, oh, Mr. Myers, really, I know how to do this. Right? But there's a reason that I'm doing this. The very next thing, radical equations, is something totally new to all of you. To do that right, you need to be able to factor at the same efficiency as you solve a math problem like this. So you can all solve that super easily and super quickly. But in order to do this, you have to be able to do factoring as quickly as you could solve that. That is why I'm giving you so much practice. Trust me, I've taught the course more times than you've taken the course. I know what I'm talking about. You need this much factoring practice. You need it. Especially, and listen to me, if you hear nothing from me in this whole unit, hear this next sentence. The rest of math puts factoring on a level of, currently for you people, of addition. That is how basic to the rest of math factoring skills are. Just like there is no way you could do this class if you didn't know how to add, there is no way you can go beyond here if you can't factor as quickly and as easily as you can add. Do you understand? If you are not planning on going any further with your math, then take the easy way out, because I can't stop you. But if you are planning on doing any math course at any institution, including this one, after June 2019, you better be able to take factoring out back and show it what it's like. Understand? Okay, go.